It's a noble gas element, and today is this topic we are going to complete. But it's a p block element. So noble gas element. Are you able to see beta whatever I wrote on the board? 1 second, let me check here. Very good. Now, in this noble gas elements, man, we are going to see according to NCRT and according to the textbook for exam point of view. First one, I want to discuss xenon, xenon, fluorine compound. See, but exam point of view, xenon fluorine compound. For example, xenon difluoride. The first one, which one we are going to discuss, that is a xenon difluoride. But what is the formula of xenon difluoride? You know, XeF2. But XeF2, how to prepare? When xenon is combining with the fluorine, it forms the XeF2. Xenon combining with the fluorine, what it gives? It gives rise to XeF2, right? But in this case, 1 second. But if you want to see the pressure, temperature in NCRT level, they gave 673 Kelvin is the temperature, 1 bar pressure, and it should be sealed in a nickel tube. 1 bar pressure, it must be sealed in Ni, a nickel tube. It gives rise to XeF2. But the solution which have the pungent smell due to XeF2 are powerful oxidizing agent. The solution means the solution which have pungent smell, small solution which have pungent smell due to what beta? XeF2. Due to XeF2 are act as a powerful oxidizing agent. Are powerful oxidizing agent. For example, I want to tell you XeF2 in H plus ion. In H plus ion by gaining 2 electrons. See beta, it will be converted into the Xe plus HF. And in our textbook, they gave the SRP value, that is E naught value, that is equal to plus 2 point something exactly, I didn't remember, but 2.64 volt is a SRP value was given. That means our xenon difluoride, when it react with the hydrogen, it form the HF and xenon. Xenon difluoride on reacting with hydrogen, it form HF. 2 hydrogen, 2 fluorine came off, and we got the xenon. Now, hydrolysis reaction also we have to check it here. But hydrolysis, shall I write here on this part? Hydrolysis is a slow in water due to dissolution of XeF2 in HF form, but is rapid in basic solution. So I should say hydrolysis of XeF2. But if you want to do in basic solution, it become rapid, fast. But if you are doing the hydrolysis in water, it become a very slow. So hydrolysis of XeF2 in water is slow due to dissolution of XeF2 in HF. Dissolution of XeF2 in HF form, but rapid in basic solution, but fast or rapid, but rapid in basic solution, right? Example I'll show you. XeF2, it undergoes hydrolysis and form Central atom has the vacant orbital, tendency to undergo hydrolysis and form Xe plus HF plus oxygen. See beta, note down. But if the same if you want to do in a basic medium beta, so basic medium means alkaline medium. OH minus ion should be there. And what it form? It form Xe plus it form O2 gas. We have to balance it. It form fluoride ion and it form water molecule minus one. Remaining you have to balance it. Correct, beta? So these are the reactions of complete a xenon difluoride. It is a compound of xenon with a fluorine. Take a screenshot, beta. Next one will go xenon tetrachloride. Or very good. Now the another compound according to NCRT will write beta xenon tetrafluoride XeF4. XeF4. Xenon tetrafluoride XeF4. The first one we saw xenon difluoride XeF2. Second compound with xenon and fluorine is a xenon tetrafluoride. But a xenon tetrafluoride means what it should be XeF4. Good. Now listen here. First method of preparation same like a XeF2 what we did. So xenon on combining with fluorine and it gives rise to XeF4 make it 2 mole. Previously temperature 673 K but now it become a 873 K. Previously pressure is 1 bar but now 7 atmos 7 bar pressure and it will be heated in a sealed Ni tube. Nickel tube will be same. We got the XeF4. But XeF4 react violently with water and give dangerously explosive XeO3. This XeF4 it react with water explosively means not only react with it react with water, it reacts with water violently means it will make it explode and it gives rise to the compound called as a XeO3 and this XeO3 compound which is obtained it is dangerously explosive. It is dangerously it is dangerously explosive. This xenon tetrafluoride on hydrolysis gives rise to explosive compound like a XeO3 which is dangerously explosive. Is it clear? I want to show you reaction also. See beta, xenon tetrafluoride undergoes hydrolysis has a tendency to form the compound called as a XeO3. Is it clear beta? Very good. Beta with that one it will form the byproduct xenon. Hydrogen fluorine is there has a tendency to form vapors of HF and it gives rise to O2 gas. We got the XeO3 as a explosive compound. Is it clear? Xenon hexafluoride now. After tetrafluoride, the third one is xenon hexafluoride. But a xenon hexafluoride means what? XeF6. XeF6. Right, beta? In this case, right, beta, in this case, xenon on combining with a fluorine and it gives rise to XeF6 pakka. If you want to balance it 3 mole, right? Temperature 573 K according to textbook value. Pressure, it is a 60 to 70 bar. Initially 1 bar, then 7 bar, then 60 to 70 bar. Same sir, it is also sealed in a nickel tube and it formed the XeF6. But the XeF6 which is formed, it is in solid form, right? Another method is there to form the XeF6. But the XeF4 on treated with a compound of oxygen with a fluorine and it formed XeF6 plus O2 gas came off, right? Note down but up to here. But it reacts, XeF6 is there, kada, it reacts with water violently, but slow hydrolysis with the atmospheric moisture, giving rise to XeO3. Same way, XeF6, it react with water violently. It also has a tendency to react with the water violently. XeF4 also violently. Reaction of this one is XeF6 undergoes hydrolysis, has a tendency to form the compound as a XeO3 plus HF vapors. But another possibility is that it also has a tendency to form XeO2F2 and HF vapors. But XeO2F2 plus HF vapors. Shall I tell you what is the difference between these two reactions? The first reaction is a complete hydrolysis. So what to say beta? Due to complete hydrolysis, it gives XeO3 and HF vapors. And due to incomplete hydrolysis, what it gives? XeO2F2 and HF vapor. That is the difference to remember. Right? Please note down. But now xenon oxygen compound we'll see. These all are xenon fluorine compound over, right? Now we'll see xenon oxygen compound. Xenon oxygen compound. But in xenon oxygen compound, first of all, we'll talk about formation of a compound called as a XeO3. The first one I will discuss about XeO3. How the XeO3 will form? Just now we saw beta. Xenon tetrafluoride on hydrolysis gives rise to, yeah, xenon tetrafluoride on hydrolysis, it gives rise to oxide of xenon plus xenon HF and O2 plus xenon HF and O2. It is a one method to prepare the compound of oxide, this xenon with the oxygen, xenon oxygen compound. Another one, hexafluoride undergoes hydrolysis. Xenon hexafluoride, it also undergoes hydrolysis and form XeO3, but the remaining is a vapor of HF. So it is another method to prepare XeO3. Whatever we saw previously, the same methods are there, beta. No other new methods are there. They all are the same method. Right? This is the one case. But a second possibility is that it may also form the compound called as a XeOF4 and XeOF2, right? So XeOF4 and XeOF2, these are the compound formed by xenon, oxygen and fluorine. What to do beta here? Partial hydrolysis of partial hydrolysis of partial hydrolysis of xenon hexafluoride. It gives the compound called as a oxyfluorides. It gives a compound called as a XeOF4 and it gives a compound called as a XeOF2. Right, beta? O2F2, sorry. XeOF4 and XeO2F2. Let me give one example for you. Beta, it is a XeF6 and if you'll do partial hydrolysis over it, by doing the partial hydrolysis, what it may have a tendency to give beta XeOF4 plus vapor of HF. Same way, XeF6 again undergo partial hydrolysis. It also has a tendency to form this kind of the compound called as a what? XeO2F2. Remaining product of vapors of HF. It doesn't matter. XeO2F2, XeO2F2. So these are the product obtained by the partial hydrolysis of XeF6. Is it clear? Chalo, note down. But the last one we will write compound, their hybridization, oxidation state, right? Number of electron or lone pair of electrons on the central atom and the shape. That is the last part. In this one we'll write. Because in exam they are asking these things only. Product obtained by the partial hydrolysis and what is the nature of this compound. That is the only part mostly they are asking even in the exam. Actually, this chapter is having the much important part only of the compound formed by the xenon, oxidation state of xenon, hybridization of the central element xenon, and number of lone pair of electrons and shape. Now, these the things I am going to give for you. But I'll write the name or the formulas of some compound. After that, I should get the uh, oxidation state of xenon, right? Then I should get the hybridization of xenon. What is the hybridization of the xenon? After getting the hybridization, we should know number of lone pair of electrons. And lastly, we should write the shape of the molecules. But the first one we'll write here. Compound formed by xenon, XeF2. Compound formed by xenon with fluorine, XeF4, XeF6. But a compound formed by xenon, XeOF2, O2F2, OF4. Is it clear, beta? XeOF2. OF2 means OF2, O2F2. 4 plus 2, 6. 2 plus 2, 4. 4 plus 2, 6. Possibility is there, beta. So XeO2F2. Sixth one is XeO2F2 and we can write one more XeOF4. XeOF4 and last one beta XeO 3 will write better way. 3 into 2 6. 4 plus 2 6. 4 plus 2 6. 2 plus 2 4 6. Possibility is there that we wrote here. Oxidation state of xenon beta minus 2 become plus 2. It become plus 4. It become plus 6. It become minus 2 minus 2 minus 4 become plus 4. 4 to 6 plus 6. Here beta minus 2 minus 4 minus 6 plus 6. Here also plus 6. Oxidation state of xenon I wrote. Then hybridization you can check it beta. It become sp3d. You know, according to chemical bonding, we are able to find a hybridization state of the central atom. sp3d, sp3d2. How it is here? I'll show you. Central atom xenon. Actually, according to our chemical bonding का concept 1/2. But a xenon के valence में 8 electrons are there. plus monovalent is 2 is there, right beta? 8 plus 2, 10 by 2, 5. Z की value 5. 5 means 3 plus 2, 5. sp3 diiode. In this case, xenon get it. Beta 1 by 2. Xenon number of electron in the valence shell of xenon is 8 plus monovalent is beta 4. 8 plus 4, 12. 12 by 2, 6. Z की value 6. It become sp3d2. 3 plus 2, 5 plus 1, 6. In this case, beta xenon, see here, 1 by 2. Number of electron in the valence shell of xenon how many? 8 plus monovalent how many? 6. Beta 8 plus 6, 14. 14 by 2 become what? 7. 7 and a what? sp3d3. Here beta xenon, electron in the valence shell of xenon 8. Monovalent is 2. Oxygen should not, we should not count. Only monovalent you have to count. How beta 8 plus 2, 10. 10 by 2, 5. 5 and a sp3d. In this case, xenon, 8 plus 2, 10. 10 by 2, 5. sp3d. 8 plus 4, 12. 12 by 2, 6. 6 means sp3d2. But here, it become a, how many? 8 by 2, 4. sp3 type of the hybridizations. Any doubt, beta? So these are the way to find out the hybridizations of the central atom in the given compound, and that formula we used, whatever the formula we use in our chemical bonding assembly. Now we know Z equal to 5 beta here. Z equal to 5 and a number of bond pair plus number of lone pair. But a bond pair means how many atoms are there surrounding xenon? 2. So bond pair is 2. For getting Z value 5, how many lone pair I should give? 3. So in this case, number of lone pair is 3. But a Z value here, 3 plus 2, 5 plus 1, 6. Pakka? Yes, sir. Z value 6. But you should know bond pair plus lone pair. How many surrounding atom around xenon? 4. So bond pair 4, making 6, lone pair 2. Lone pair is 2. But I'm rounding only for number of lone pair. Here, Z value 3 plus 3, 6 plus 1, 7. Good. Z equal to number of bond pair plus number of lone pair. Bond pair means central atom surrounded by how many atoms? 6. So bond pair 6, lone pair should be 1. Then only 6 plus 1 Z value equal to 7 we will get. 3 plus 2, 5. Z value 5. Z equal to bond pair plus lone pair. Bond pair how many? 2 plus 1, 3 beta. 3 atom, 3 bond pair. Lone pair should be 2. Here, Z value 5. Z equal to bond pair plus lone pair. Bond pair central atom surrounding 2 plus 2, 4. 4 atom, bond pair 4. Lone pair should be 1. Z equal to 3 plus 2, 5 plus 1, 6. Z is equal to number of bond pair plus number of lone pair. Beta bond pair how to get? Central atom surrounded by how many atom? 1 plus 4, 5 atom. So bond pair 5, lone pair should be 1. Here Z equal to 4 for this one. Z equal to bond pair plus lone pair. Beta bond pair central atom surrounded by 3 atom. Bond pair 3, your lone pair should be 1. See beta lone pair 3, lone pair 2, 1, 2, 1, 1, 1. Right shape. It is a linear because sp3d na beta. 3 lone pairs are there. Only 2 fluorine away from each other. It is a square planar. Right? Another one is, I'm talking about shape, not a geometry beta. Geometry decided by the value of Z. Shape decided by the number of lone pair present around the central atom. Distorted pentagonal bipyramidal. Distorted pentagonal bipyramidal. Distorted pentagonal bipyramidal is the shape form as XeF6. Then another one is XeOF2. It become T shape. How it become T shape. Distorted trigonal bipyramidal. Shape for XeOF2. right? But XeOF4 square pyramidal. XeO3, it is a only pyramidal. Down beta.
Sir, I have your doubts, sir.
Yeah, beta, tell me.